Well, let's take this opportunity to explore one of the four key working fluid circuits utilized in the Recovery 2.0 process. Today, we wish to focus on the water-steam pipeline. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Within the Recovery 2.0 process, we have focused a great deal of effort on energy recovery in an effort to manage the energy continuum while attempting to maintain a balance or equilibrium with our environment. One of our objectives involves the treatment of wastewater and brines with the goal to recover these resources, along with the water that is contained or embedded within other waste materials. We strive to maximize the efforts to produce clean water, primarily for use in sanitation, irrigation, and as a raw feedstock for potable drinking water. In the evolving age of decarbonization and electrification, water may also play a critical role in the energy generation sector. The Recovery 2.0 approach to water recovery starts with the thermal reduction process, where heat is applied to evaporate or distill wastewater in order to purify and recover clean water. When you evaporate wastewater and brines, you end up with a concentration of mineral salts and a variety of other residues. Any responsible recovery program needs to address the management of this salts residue fraction. We will discuss the mineral salts concentration, selective extraction and recovery, in greater detail at another time. When sufficient heat is applied to wastewater, it invokes a phase change reaction, converting from liquid water into a water vapor or steam. This gaseous vapor has a volumetric expansion ratio of about 1,600 times. When contained within a closed system, this steam expansion is exhibited as an increase in pressure. Harnessing the steam pressure as the energy to drive a turbine is the basis of most thermal power generation worldwide. This process is known as the steam Rankine cycle. The Rankine cycle turbine rotates a generator, which in turn produces electricity through an electromagnetic induction process. The exhausted heat from this process may be used to heat water, that may be circulated as a means to distribute hot water heating. Steam may be consumed as a reactant in many chemical reactions, otherwise the steam may be used as a medium to distribute heat to many industrial processes. When steam is condensed back into liquid water, energy may be harnessed in a steam condensing engine, which may be used to pump water or compress air. The resulting hot water recovered from the condenser is a distilled clean water product. The heat contained in the recovered hot water may be harvested in a heat exchanger to drive an organic Rankine cycle or a Stirling engine, to further power pumps or electric generators. Your choice of either wastewater or clean water may be engineered as a working fluid, and may be circulated to act as cooling water and a method to extract and transport heat. Clean water is a typical feedstock in an electrolyzer, which may split water into hydrogen and oxygen. When hydrogen and oxygen are recombined, they generate electricity, and the byproduct reforms into water vapor. Separating hydrogen and oxygen into two individual streams, you may produce a valuable feedstock for any number of industrial processes, or as an alternative, these materials may be sold as an output product. Hydropower, harnessing the energy of falling water, is an effective and reliable method of generating electricity. Hydropower has the ability for a rapid ramp-up on demand to operate hydroturbines. Hydro energy storage is the process where water is pumped from a lower potential reservoir to a higher potential reservoir. The water in the high potential reservoir may sit in an idle state at ambient temperatures awaiting dispatch on demand. Within the Recovery 2.0 system, hydropower is our preferred path for energy storage, since any sporadic, intermittent or variable motion throughout our process may be harvested and converted into pumping power, and subsequently charges our hydro storage battery. By designing a hydro accumulator tower system, water may be pumped into a bank of pressurized hydro storage tanks, which allows for the accumulation of potential energy on a regenerative basis. By tapping into various processes across our system, we may harvest energy with the use of liquid piston Stirling engines, thermal siphon water circuits, and expansion tanks. This gives us the opportunity to harness energy that otherwise may have gone untapped. The Endless River, in an attempt to design a continuous flow of water with a short cycle regeneration strategy, the Endless River has been adopted as part of the hydro water regeneration cycle. In summary, the water-steam pipeline is a method to recover clean water from waste, and to also both recover and store energy, while maintaining a balance or equilibrium with our environment. We intend to discuss additional facets of the energy and resource recovery sector at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.